Neil deGrasse Tyson once said, "The universe is not only bigger than we can imagine, it is bigger than we can even comprehend." This profound statement raises the fundamental question, does the universe have a beginning and an end? And has the James Webb Space Telescope, JWST, finally discovered the edge of the observable universe? For centuries, humans have been fascinated by the vastness of the cosmos, constantly seeking to understand its size and boundaries. In ancient times, the edge of the world was thought to be just beyond the horizon. With advancements in technology, we now use powerful telescopes to explore the universe, searching for clues about whether it has finite limits. The JWST, with its cutting-edge technology, might have made significant strides in answering this age-old question. When we ponder if the universe has an edge, it's not simply a matter of yes or no. The universe undoubtedly has boundaries, but these boundaries might not be the ultimate limits of everything. They could be thresholds leading to other universes or dimensions that we don't yet understand. Just as our Earth has edges, and our solar system and galaxy have boundaries, the cosmos extends far beyond these familiar limits. Neil deGrasse Tyson is right, the problem lies not with the universe but with our limited understanding. The universe is so vast that it defies our imagination. Our current tools, though advanced, are still relatively basic when compared to the enormity of the cosmos. Using our telescopes, we can observe about 46.5 billion light-years in every direction, giving us an observable universe approximately 93 billion light-years across. Even within this immense expanse, we haven't found an end. The sheer number of stars, galaxies, and cosmic phenomena we've discovered is staggering, and it would take thousands of years to explore just the parts we already know about. Despite these challenges, our insatiable curiosity drives us to keep searching. We yearn to know if the universe has an edge and what that edge might look like. The JWST is a critical tool in this quest. This powerful telescope peers into the darkest parts of the universe, uncovering fully developed galaxies that challenge our current understanding of cosmic evolution. As humans, we tend to think of everything as having a beginning and an end. We like to deal in concrete facts and spatially limited structures. However, anyone who delves into the study of the universe quickly realizes it stretches the boundaries of thought and perception. The vast size, the countless stars, the myriad planets, and the bizarre cosmic phenomena we observe all challenge our understanding. Astronomers and cosmologists must therefore be open-minded and imaginative. Yet, even they sometimes realize their thinking has been constrained by old paradigms. The JWST is pushing the limits of space research. Some of our most cherished theories and accepted truths are being questioned. Just as people once had to accept that the Earth is round, we may soon have to adjust our understanding of the universe. For instance, the JWST has revealed 6 galaxies that are so old and perfectly developed that they shouldn't exist according to our current theories. The telescope was expected to show us the dark ages of the universe, a time when the first stars were forming. Instead, it has shown us rows of fully formed and very ancient galaxies. So, we truly seeing the beginning of the universe? Did the dark ages actually exist, or were they just a concept we created due to our lack of knowledge? These 6 galaxies are just one of the many surprising discoveries made by the JWST. The telescope also found a massive cluster of galaxies that existed much earlier than previously thought possible. This discovery challenges our understanding of how stars and galaxies form. We believed stars formed first, followed by star clusters, galaxies, and finally galaxy clusters. But finding a galaxy cluster from a time when the universe was still very young forces us to rethink this process. The JWST has discovered countless galaxies with a redshift greater than 10, indicating they are very old and far away. Neil deGrasse Tyson aptly states, "The problem is not the universe, the problem is us, because we think we know more than we actually do." The JWST continues to reveal more galaxies and cosmic phenomena than we ever expected, constantly challenging and expanding our understanding of the universe. In summary, while the universe is unimaginably vast and complex, our quest to understand it continues. The JWST is a pivotal instrument in this journey, providing new insights that challenge our existing theories and push the boundaries of our knowledge. As we explore further, we might realize that looking for finite limits might be the wrong approach. The universe, with its infinite possibilities, encourages us to think beyond our current understanding and embrace the boundless nature of the cosmos. During a period known as the Dark Ages of the universe, the James Webb Space Telescope, JWST, made an astonishing discovery. Most of the galaxies it found from this early time have a redshift greater than 10. Redshift is a way of measuring how much the light from these galaxies has been stretched due to the expansion of the universe. A redshift greater than 10 indicates these galaxies existed when the universe was just 2% of its current age, which is only a few 100,000 years after the Big Bang. These discoveries revealed a universe that looked much like it does today, contradicting the expectation of a dark, empty void during that period. The findings from JWST were so incredible that scientists initially questioned their validity. However, the telescope's spectroscopy capabilities confirmed every single result multiple times. Spectroscopy is a technique that breaks down the light from an astronomical object into its various wavelengths. This method allows astronomers to determine the age of the light source and its physical properties, such as chemical composition. By using spectroscopy, JWST provided evidence that these distant galaxies are not only very old but also contain elements and a number of stars that don't align with the characteristics of a young universe. As we continue to observe the universe, the temporal edge, or the limit of what we can see in time, keeps moving further away from us. But what about the spatial edge, the physical boundaries of the universe? This question presents a paradox because if we are looking for something that exists in space right now, we need to see it in real time. Imagine you are in a very large concert hall that is mostly dark, except for a few small LED lights 10 or 20 meters away. You can't see the walls, so you would have to feel your way around to find the edges. In the cosmos, we can't travel through space personally, so we rely on telescopes to extend our vision further and further into space. The JWST allows us to look deeper into the universe, but there's a catch: the universe is expanding as we observe it. It's like trying to spot the walls of a room that keep moving further away as you look at them. This makes finding a spatial edge even more challenging. Additionally, light takes time to travel through space. With the JWST, we see light that has traveled for light years, 1,000 light years, or even 13 billion light years to reach us. This means we are always looking at the past. To put it in perspective, the nearest star to us, Alpha Centauri, appears as it was 4 years ago because that's how long its light takes to reach us. This concept becomes even more staggering when considering galaxies billions of light years away. We know that the universe must have been smaller 400,000 or 5 million years ago because it hasn't had time to expand to its current size yet. Despite this, we haven't found any signs of a spatial limit. Instead, we've found evidence suggesting the universe isn't expanding uniformly, which implies that it might not have a homogeneous structure. As we explore further with the JWST, we might come to realize that searching for boundaries or a beginning could be a flawed approach. This new era of space exploration might be showing us that we need to think beyond limited dimensions. The JWST repeatedly finds structures that break these boundaries, suggesting a universe without limits. For instance, the telescope discovered a distant galaxy with an enormous active galactic center. This galaxy, seen just 570 million years after the Big Bang, hosts a quasar with a black hole 10 times the mass of our Sun. These quasars, part of active galactic nuclei, emit an extraordinary amount of light produced by the friction of material spiraling into the black hole. Such galactic centers shine trillions of times brighter than the brightest stars. Even in its search for exoplanets, the JWST continually challenges our understanding of limits. An example is HIP 65426b, a massive gas giant 12 times larger than Jupiter. This planet was first identified by the Hubble Space Telescope in 2017. Thanks to JWST's advanced capabilities, we now have even clearer data on this distant world. HIP 65426b is located at a distance from its star that is 100 times greater than the distance from Earth to the Sun, more than twice as far as Pluto is from the Sun. Using JWST's coronagraphs, cameras, and various filters, astronomers have directly imaged this planet for the first time, which is rare since most exoplanets are discovered by other indirect methods. These discoveries illustrate that the universe is filled with phenomena, peculiarities, exceptions, and ever new dimensions. It would be foolish to look for a definitive end, edges, or limits. Instead, we should embrace the endless possibilities and continue to explore the vastness of the cosmos. The JWST shows us that our universe is far more complex and boundless than we ever imagined, urging us to think beyond our current understanding. Subscribe to the channel now and be part of every new video highlight as we continue to uncover the mysteries of the universe.